So we're going to discuss finding zeros or roots when given a graph. Zeros and x-intercept solutions and roots, they all mean the same thing. Typically, when you see a function f of x, you will see the directions that will say zeros and x-intercepts. And if you see like y equals, that's an equation. So it typically would say solutions or roots, but they all mean the same thing. It basically means that if I have a graph and I have points on my x-axis, those are going to either be zeros, x-intercepts, solutions, or roots. That's what that means. So make sure you understand terminology. If I am given the actual, in this instance, a function, and I know it's a function because it has f of x in front of it, and I'm given the graph as well, what I would advise that you do is highlight the x-axis. And for now, we're going to pretend that we only see one point, but I actually see three. So I'm going to just go ahead and choose the point, actually 3. And I know it's 3 because if I'm counting, looking at my units, I see they're counting by 1. So 1, 2, 3, 4, 5. So you have to pay attention to the units because they don't always count by 1. All right, so now what I would like to do is I'm going to use that 3 in a synthetic division situation. So there's my 3, which represents my 0. And then I'm going to take my coefficients and my constant from my problem. So I have a -1, 2, 5, and -6. I also want to make sure when I'm taking that information that it's in standard form. So I have 3, 2, 1, and then a constant. If something is missing, I have to remember to use my 0 placement holder. Okay, so now to start the process, I bring down that first number and then I will multiply everything below the line times the divisor, and everything above it I will add. So -1 times 3, -3, 2 plus -3, -1, -1 times 3, -3, 5 plus -3, 2, 2 times 3 is +6. And if this is not 0, that means I'm doing something wrong, because it shows me on the graph that at 3, my y is 0. Remember, f of x really is y. Okay, so whenever I put a 3 in for x, that's what this means, my outcome will be 0, which is the y. That's what that means. So now what I'm going to do is I'm going to continue on. So I know that if I started with x to the third, my new degree is now x squared, because these are my new coefficients and my constant. So x squared minus 1x plus 2. So if I were trying to factor this, the first thing I would do is factor out the GCF of -1. I know though, when I actually do that, it's not going to be factorable. So what I would like to do then is go back to what I know about the quadratic formula. So that is x is equal to -b plus or minus square root of b squared minus 4 times ac, all divided by 2a. I'm going to take that information, which is the coefficients and the constant, and I'm going to substitute it into the quadratic formula and solve so that I can find my other zeros. So I'm just going to actually start my set. So I know I have a 3 here, and based off of my highest degree, I know I'm going to have 3 answers here. So let's continue working until we can find that. So substituting what I know, x is equal to b is -1 as well. Make sure that you understand that negative is part of your formula. So put your b in parentheses so you don't forget to keep both of them. Plus or minus, b is still -1, and this time it's squared, minus 4 times a, which is -1, times c, which is 2. All of that is going to be divided over 2 times a, and a again is -1. All right, so a is -1 and b is -1. C is +2. Now that I have that information substituted into my quadratic formula, I can continue to simplify. When I simplify, negative times negative becomes a positive. So x is a positive 1 plus or minus. And then this negative 1 squared becomes positive 1. 1, and then negative times negative is positive 4. Positive 4 times 2 is positive 8, divided by 2 times 1, which is negative 2. I continue to simplify. This becomes 1 plus or minus square root of 9. Well, the square root of 9 is really 3. So this is 1 plus or minus 3 all over negative 2. This is two separate equations. So x is going to equal 1 plus 3 over negative 2. And it's also going to equal 1 minus 3 all over negative 2. And when I simplify, 1 plus 3 is 4. 4 divided by negative 2 is negative 2. And then here, 1 minus 3 is negative 2. Negative 2 divided by negative 2 is positive 1. So I have my other two zeros as well that I'm going to put in the set here. So I have negative 2 and negative 1. That is the answer. Wait a minute, that should be a positive 1. I wrote that down wrong. Positive 1. I have to be able to read my own writing here. Okay, so my answer should be 3, negative 2, and 1. Okay, and that's finding the zeros for, and if I looked at my graph, I could already tell that. Like I said, I just need you to understand how to use the synthetic division. And also if you need to use another method like the quadratic formula, this is how you would do it. But if I went back here, I see a positive 1, which is what that is. And I see a negative 1, negative 2, a negative 2. So I can verify on my graph that those points are in fact correct. If I have a graph that looks like this, again, the first thing I would do is I would highlight my x-axis, and then I can clearly see the points. But again, I'm just going to pick one of them to work with. Let's go with this one. This is negative 1. And so what I want to do is, again, use that as my divisor for my synthetic division. And this time I notice it goes from exponent 4 and it goes to 2. So I have to be aware of that so that I can put in a 0 placeholder. So 1 is the coefficient. I don't have x to the third, so I have to put a 0 there. X squared is negative 4. I don't have an x, so I have to also put a 0 there. And then my constant is 3. You really have to pay attention to that because some people will remember to put the 0 here and forget this one, or vice versa. Now we start the process again, bring down that 1, multiply, negative 1, add. So that's going to be negative 1 times negative 1, positive 1, negative 4 plus 1, negative 3, negative 3 times negative 1, positive 3, 0 plus 3 is 3, 3 times negative 1 is negative 3. And again, I know that I'm going to get 0 because that's what my graph told me, that at negative 1, my y would be 0. If I get anything else, I am doing something wrong. All right, so in this case, I still have a lot of coefficients and a constant. So this is true. This is really x to the third minus x squared minus 3x plus 3. So I want to do I want to go ahead and do another synthetic division. And again, since I have my graph, I can just clearly see that 1 is also a point. So that's what I'm going to use, 1. But this time my coefficients are the ones that are under the line. So I'm going to use 1, negative 1, negative 3, positive 3, because it's in the standard form 3, 2, 1, and then the constant. Bring that down and I start the process. 1 times 1 is 1, negative 1 times 1, 0, 0 times 1 is 0, negative 3 plus 0 is negative 3, negative 3 times 1 is negative 3, and again, I see that I have 0, which I already knew because that's what my graph tells me, but I am still not finished. So this was x cubed, so that means I go down a degree. This is x squared plus, this is simply x minus 3. So what I personally would do is I would look at this as x squared, and I wouldn't write the plus x part, the plus 0x. I would just go to the constant, which is minus 3. And since I'm solving, there's an equal here, equals 0. If I ever see that my x term is missing, I can use the square root method. So that's what I'm going to do. So square root method means I'm going to move all the constants on the opposite side of the equal sign, and I'm going to leave the x squared on the left-hand side, or the side where it's positive. So this is what I have. So I have x squared is equal to 3. If you recall, for the square root method, you would take the square root of both sides, but on this side, you have to use your plus or minus first and then take the square root. All right, when I do that, that gets rid of that square and it leaves me with x is equal to plus or minus square root of 3, because I cannot simplify the square root of 3. Well, I look at my highest degree and I should have 4 zeros. So let's see what my zeros are. I cannot forget that I've already used 2 of them in my synthetic division. So I'm going to take negative 1. I'm going to take the positive 1. And now I've just come up with 2 answers here because x squared told me I would have 2 answers. I have a positive square root of 3, and I have a negative square root of 3. So in total, I have 4 zeros, 1, 2, 3, 4. And you can put it in the correct order as far as like from counting upward. It doesn't matter. This is your answer here. Okay, and let's try one more. Again, I'm given this time an equation. I don't think I said that a few minutes ago. So you may see the word solutions or let's go back up here. So solutions or roots in your definition or your instructions. And this is what the picture, the graph will look like. And again, just looking at it, I'm going to highlight my x-axis. Sometimes you can clearly see points and sometimes you can't. So it just really depends. All right, so I think I want to work with this positive point over here, which happens to be 1, 0, 1. All right, so starting with my synthetic division, I'm going to, again, I see that it's already in standard form, 3, 2, 1, so I don't have to use any zero placement holders. I just use the coefficients, 1, 4, 1, and negative 6. And I start my synthetic division process, multiplying everything that's below the line and adding everything above. Bring down that first coefficient, 1 times 1, 4 plus 1, 5 times 1, 1 plus 5, and 6 times 1. Again, I'm looking for 0 whenever I clearly see the point on my x-axis. That tells me my remainder is going to be 0. So now if I go back in and I put in my new variables, it's going to go down 1 degree. So that's going to be x squared plus 5x plus 6. Now, if I look at this, I could actually factor this one. So let's try that. And maybe it'll help you to see it rewritten. So I'll just write it up here, x squared plus 5x plus 6. Well, x times x is what's going to take up this first term. Both signs are positive, so I know I'm going to have a plus and a plus. And then I can use my A times C method, or I can use the box method. It's up to you. Let's just do the box method for the fun of it. So if I'm using my box method, that first term is going to be in my first box. The last term will be in the last box. I need to find 2 numbers when added together will give me that positive 5, but when they are multiplied, it will give me the 6. So I know that's going to be a plus 3 and plus 2. I have to remember I'm trying to replace 5x, so this should also have the variable x next to it. Now, if I'm trying to factor, I want to factor out. For me, I go to the left. So I'm going to go, okay, doesn't want to, my pen doesn't want to change. There we go. I'm going to go to the left. And the greatest common factor between x squared and 3x is going to be x. And then the greatest common factor between 2x and 6 is going to be a positive 2. So I know that's one of my factors. So I already have the x plus, I can just put the 2 there. And now going in the other direction, which is vertical, I would do the same thing with my columns. So what is the greatest common factor between x squared and 2x? Well, it's simply x. And then here, what's the greatest common factor between 3x and 6? Positive 3. So I have my other factor. The original problem is set equal to y, which really means it's set equal to 0, which means each of these binomials will need to be set equal to 0 so that I can find the actual zeros. I already have one of my zeros, so I know 1 is one of my zeros. And then when I set this equal to 0, x plus 2 equals 0 is going to be x equals negative 2, because I'm just going to subtract 2 from both sides, and then I'm left with negative 2. It will always be the opposite sign of what's shown if there is a, it's always the opposite sign. So if there's a positive 3 here, I know that when I set x plus 3 equal to 0 and solve for x, it's going to become negative 3. So again, if I am looking at my highest exponent, or my highest degree, same difference, I should have 3 answers. I should have 3 zeros, and I do. 1, negative 2, and negative 3. The order does not necessarily matter for me, but it depends on your teacher. So if they want you to, what is going on? They want you to write it in a specific order from lowest to highest, then make sure you do that. Okay, so that's it for me. Hopefully that helped you understand how to actually find your zeros whenever you are given a graph. You can also look at my other video, which tells you how to use your calculator.